We are continuing to look at problems with 4 terms. Notice that number 6 has 1, 2, 3, 4 terms. Looking across here, I don't have a greatest common factor. So I don't have anything that I need to pull out to start with. I can jump right to doing my factor box. I'm going to write these in any order that I want to. I tend to just write across the top row and down and then across the bottom row, but it honestly doesn't matter. 5z cubed, 5z squared. Negative 6z, negative 6. And I'm ready to look for greatest common factors across each row, down each column, just like we've done several times before. Across the first row, I see a 5 and a z squared. Across the second row, I see a negative 6. Looking down the first column, I see a z. And looking down the second column, well, I don't see anything they have in common, so I'm going to call it a 1. So now I can write these factors over here as my next line. After I've done my factor box, I'm going to write 5z squared minus 6 and z minus 1. All right, I have a linear term here, so that means that I'm done with that one. I need to focus in on this 5z squared minus 6. Now I notice that it's 2 terms and it's a squared here. So the only thing I could be looking for is difference of 2 squares. If it's not difference of 2 squares, it's definitely not 2 cubes because we have a z squared. So this is the only thing that we could have, but it's not this, so it's not going to be factorable. I know that these aren't perfect squares because, well, 5 is actually a prime number and 6 is not the perfect square of anything. So we have a linear factor and a quadratic factor that cannot be factored more. And so we can say, once again, that we're done.